Hi, welcome to Intersoft Solutions video tutorial. My name is Andrew. In this video, I'll explain several new design patterns to tackle data access challenges using Crosslight. The first design pattern I want to share is called repository pattern. Repository pattern suggests that any direct data access in the business logic should be separated to an entity called repository. With this being said, the repository has the responsibility to mediate the data source layer and the business layer. It queries the data source for the data, maps the data from the data source to a business entity, and persists changes in the business entity back to the data source. Why use repository pattern? First of all, it reduces code redundancy in your application, because now all the data-related processes are centralized in the repository. Second, you can easily change the data access strategy without changing too much code. Let me show you the benefit of using repository pattern. In this example, I have two view models. The first one is item list view model, and the second one is category list view model. Both of these view models retrieve the data from a web API controller. I'm using Crosslight REST client to retrieve the data from the specified web API controller. As you can see, the codes in these view models are pretty much redundant and hard to maintain. Let's say I want to add an error handling capability in this process. Since it's not centralized, we will need to go to each view model and implement the error handling capability one by one. Not a good practice. Now, let's see how repository pattern can tackle this challenge. In repository pattern, we need to have an interface to define the data access contract for all our repositories. In this example, I have a simple interface called a data repository. This interface will enforce the data contract for all my repositories in the application. Currently, it only has one method called getAllAsync. However, in practice, it should have all the methods necessary to perform a complete data operation. Here's an example of complete iData repository interface that we have in our enterprise app framework. Let's go back to our example. After you create the interface, you will need to create a base repository class that implements the interface. In this example, I have a base repository class called REST repository. This base repository class encapsulates all the data-related processes to a web API controller using REST client. This base repository class basically a refactored code from our previous example, where we attempt to retrieve the data in the view model without using a repository. After you create the base repository class, you will need to create the repository for each business entity in your application. In this example, I have item repository and category repository that inherited from the base repository class. As you can see, the repository pattern makes our codes more clean and manageable. Let's say I want to add the error handling capability like I did in the previous example. We can just enhance our base repository class, and all the repositories that inherited from this base class will have the same error handling capability automatically. Let's see how to use these repositories in our view models. Another benefit of using repository pattern is that you can easily change the data access strategy by changing the repository used in the business logic. For example, let's say I want to create a new repository called new item repository. For simplicity, this new repository will return a collection of dummy data, but in practice, it can be a repository that accesses a new web service or SQLite storage or any other data source. After you create the repository, you can just replace the existing repository used in the business logic with the new one. By doing this, your business logic now performs the data access to the new data source specified by the new repository. As you can see, the code changes is very minimum. In Crosslight version 2, we include several repositories in our enterprise app framework. They are REST repository, entity repository, editable entity repository, local entity repository, and editable local entity repository. To learn more about the differences between these repositories and best practice of these repositories, you can go to the provided link in our developer network. The next design pattern I want to share is called query descriptor. Query descriptor is a simple metadata that can be used to store complex dynamic query, such as filtering, sorting, paging, selection, and includes. You can use the query descriptor to generate a dynamic OData query and also a dynamic LINQ expression. Let me show you how to use the query descriptor and translate it to OData query and LINQ expression. Query descriptor has a property called filter descriptors. This property contains a collection of filter descriptors that hold the filtering information. To add a new filter, simply create a new filter descriptor and specify the necessary properties as follows. In this example, I want to filter the data by the item name that starts with SA characters. You can generate the OData query using two query string methods as follows. If you want to use it as LINQ expression, simply pass the filter descriptor to the where method as follows. You can also perform a complex filtering using composite filter descriptor class. In this next example, I want to filter the data by the item name and price. I only want to get the item with name starting with an A or S. And also, the item price should be greater than 650 but not higher than 700. To do this, I need to create two composite filter descriptors, one for each grouping. After that, I add this composite filter descriptor to the filter descriptor property in the query descriptor. Notice that the composite filter descriptor has a property called logical operator. This operator will be used for all filter descriptors within the composite filter descriptor. After you finalize the query descriptor, you can use the same method to query string to generate the OData query, or simply pass it to the where method if you want to translate it to link expression. To add a new sorting, simply create a new sort descriptor and specify the property name with the sort direction. You can add multiple sort descriptors to be applied in sequence. In this example, I'm sorting the data by the item name followed by item price. To generate the OData query, you can use the toQueryString method as follows. If you want to use it as link expression, simply pass the sort descriptor's property to the order by method as follows. To paste the data, you need to specify the page size and page index in the page descriptor property. Similar with sorting and filtering, you can use the toQueryString method to generate the OData query. For the link expression, you can use the built-in skip and take method with the information provided by the query descriptor. From what we have learned, using a repository means that all the data-related processes must be encapsulated in a repository. If you have multiple selection strategy, you will need to create the methods for each selection strategy as follows. This situation can be further improved by using a query descriptor. You can use the query descriptor as a placeholder for your dynamic query. You can then let the consumer of the repository to specify the query to be used by the repository. Using this approach, your repository will only have one method that can be reused for any dynamic query that you might have in your application. This concludes my presentation about the new data access patterns that are highly used in Crosslight application. If you need more information, you can browse our online documentation at developer.introsoftpt.com or drop us an email at technical@introsoftpt.com. You can also find discussion related to Crosslight and Mobile Studio in our forums at introsoftpt.com/community/Crosslight. If this video helps you, don't forget to hit the like button and subscribe for more videos.